So the Earth's atmosphere is broken up into these horizontal layers, and the horizontal layer of the atmosphere that's closest to the Earth is called the troposphere. And as we talk about weather, day-to-day weather, actually a lot of what we talk about happens within the troposphere. The troposphere is the thinnest, so that means it doesn't go up very high in elevation, but it's actually the most dense. I almost said the thickest. It's the most dense, so it's packed with regard to gas particles. I mentioned aerosols. Aerosols are suspended liquids and suspended particles, and so where the aerosols are closest to the Earth's surface. So that's where actually in the troposphere we're going to most likely find our aerosols. The troposphere is topped by what we call the tropopause. Tropopause. You're going to see the word pause kind of as something that tops the other layers of the Earth's horizontal layers of these atmospheric layers. So above the tropopause, actually troposphere, tropopause, we have the stratosphere. So the stratosphere actually is home to that variable gas, the ozone. And we have the ozone layer up there, and I have a next slide that's going to talk a little bit about that good ozone found in the troposphere. And if you get a chance to take a look at this awesome jump by Felix Baumgartner, okay, he took a balloon up and jumped from somewhere in the stratosphere. So I think that is so cool. Above the stratosphere, we have the stratopause. Above the stratopause, we have the mesosphere. I don't really have anything really interesting to say about the mesosphere, meso meaning medium. Okay, above the mesosphere, we have the thermosphere, and the thermosphere kind of peters into outer space. And then we have this horizontal layer called the ionosphere. The ionosphere is the upper part of the mesosphere and the thermosphere. And the ionosphere is known for these, actually, you might recognize these northern lights here. Okay, Aurora Borealis. Okay, and actually they are associated with the charged particles from the sun. When I think I talked about this when I talked about the sun way a long time ago in this class. But when the sun has its 11-year cycle, and when the sun is being especially active, it sends these kind of boatload of charged particles to the Earth, and they actually, some of them are trapped. And they overload our Van Allen belts, and then they kind of eke through at the poles. Okay, so that's the 4 layers of the Earth's atmosphere. So in this class, it's a great test question. This is closest to the Earth. This is going up, 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 and the ionosphere, of course, is a combination of these two. Okay, so I want to say a little bit more about the ozone. So regular oxygen that we're breathing actually has the formula of O2. Okay, so that's just regular oxygen. Ozone has the formula for O3. So guess what? It has 3 oxygen atoms that are stuck together. So I mentioned the good ozone is in the stratosphere. And what makes it good is that actually, if this is the sun, okay, sending forth all types of EM radiation, electromagnetic radiation, including visible light. One of the forms of radiation it sends is ultraviolet radiation, and it is this ozone in the stratosphere, goodness, my writing is going to heck, ozone, okay, that actually interacts with ultraviolet radiation and kind of blocks a large part of the ultraviolet radiation. Now, the ozone in the stratosphere has been compromised by CFCs. CFCs actually now have been, I want to say, banned or entirely curtailed. They used to be a common propellant used in aerosol cans and as a puffing agent in styrofoam and such. But anyway, CFCs, the problem what they would do is they would interact with the ozone. So actually, I think no, I don't. I think I talk about the ozone hole coming up. So good ozone is in the stratosphere. It blocks incoming ultraviolet radiation. Bad ozone then is actually in the troposphere. Remember, troposphere is the lowest layer of the Earth's atmosphere. Bad ozone actually is what we call a secondary pollutant and bad ozone makes it difficult for people to breathe. And I don't live there, but or at a place where I see these ozone alerts, but I just thought that was kind of, ozone alert in the troposphere. So what is this concern about in the good ozone having this ozone hole? So I mentioned it's seasonal, and I kind of talk you through a series of kind of events that make it seasonal. I also mentioned CFCs. So what happens is that the CFCs, okay, actually interact with O2 and basically make it, or destroy O2, excuse me. The CFCs destroy ozone, O3. Now the CFCs, the chlorofluorocarbons, actually are tied up in these polar stratospheric clouds. They're just beautiful. I've seen pictures of them, and I have a link here. Maybe I'll have to kind of go to that link. But these polar stratospheric clouds are, guess where? At the poles. So they're very cold. They're very upper level clouds. Most clouds are in the troposphere. These are in the stratosphere. But these clouds tie up CFCs, and so they can't do their dirty business. Now, these clouds, these polar stratospheric clouds, when it comes springtime, basically start to kind of break up. And so in the springtime, as they break up, they release their CFCs to go ahead and do their nasty business. So they're in, they're about, let's see, what I say, oh, in the southern hemisphere, okay, the spring in the southern hemisphere is in October. And so actually the southern hemisphere in October has this, springtime has this kind of exposure, release of CFCs that attack their ozone. Okay. So one last look then at the 4 layers of the atmosphere, okay, kind of ignoring the ionosphere for now. So here we have the stratosphere. Now what I like is it kind of shows you how what kind of elevation you have the stratosphere, excuse me. Here we have the troposphere, and it kind of shows you how thick the troposphere is. It actually is the thinnest of all of them. It doesn't go up very high. And then we have the stratosphere, okay, and then we have the mesosphere, and then we have the thermosphere. Okay, so that's one thing that I like about this slide. The other thing about this slide, and I think this is significant, so sometimes I test you on it, is down here, oh, and it got cut off, didn't it? Down here along the x-axis would be temperature. Okay, so this is to say that if you're in the troposphere, if you're going up in elevation, can you see where the temperature gets cooler and cooler? So going up, it gets cooler. Okay, if you're in the stratosphere, if you're going up in that layer, it gets warmer. You're just going to have to take my word for it because you can't see the x-axis. If you're in the mesosphere going up, okay, it actually is going to get cooler again. And then if you're in the thermosphere, remember this is where it peters in outer space, it's going to get warmer again. Now I would argue that the kind of warmth has to do, to a certain extent, your vicinity to the sun. Are you on the daytime side of the Earth or the nighttime side of the Earth? But we say it generally gets warmer in the thermosphere. Okay, so there you go.